According to the National Electrical Code, also known as the NEC and industry standards, the underground polyvinyl chloride coated galvanized pipe is not considered an adequate grounding conductor. This is because the polyvinyl chloride coating isolates the metal pipe from the ground. Yes, you must bond the gutter to the grounding system to provide a proper grounding path. This is because the gutter is an exposed conductive surface that could become energized if a fault occurs in the electrical system. To properly bond the gutter, firstly, install a grounding lug on the gutter. Secondly, connect the grounding lug to the ground wire that was pulled through the conduits. Thirdly, ensure that the ground wire is properly terminated at the ground bus bar in the load center. The ground wire should be insulated and sized according to the NEC and protected from physical damage. Periodically inspect the grounding system to ensure that it remains intact and effective. The importance of proper grounding and bonding in electrical systems is paramount for safety and the reliable operation of equipment. Grounding provides a low impedance path for fault currents to return to the source, allowing overcurrent protection devices like circuit breakers or fuses to quickly interrupt the circuit and prevent electrical shock hazards or equipment damage. Bonding, on the other hand, ensures that all metallic parts of an electrical system are at the same electrical potential, reducing the risk of electrical shock if someone comes into contact with two different metallic parts. Gutters, being exposed conductive surfaces, can become energized due to various reasons, such as insulation failure in nearby wiring or lightning strikes. If a gutter is not properly grounded and bonded, it can pose a significant electrical shock hazard to anyone who touches it. Therefore, the NEC mandates that all exposed conductive surfaces, including gutters, be bonded to the grounding system. When dealing with underground polyvinyl chloride coated galvanized pipe, it is essential to understand that the polyvinyl chloride coating acts as an insulator, preventing the metal pipe from making direct contact with the earth. This means that the pipe itself cannot be relied upon as a grounding conductor. Instead, a separate grounding conductor, typically an insulated copper wire, must be installed inside the conduit and connected to the grounding electrode system. This grounding conductor provides a dedicated low impedance path for fault currents, ensuring that the electrical system is properly grounded. The process of bonding a gutter to the grounding system involves several steps. Firstly, a grounding lug must be securely attached to the gutter. This lug provides a connection point for the grounding conductor. The grounding lug should be made of a material that is compatible with the gutter material to prevent corrosion. Secondly, the grounding conductor is connected to the grounding lug. The grounding conductor should be sized according to the NEC, based on the size of the circuit that it is intended to protect. The connection between the grounding conductor and the grounding lug must be mechanically sound and electrically conductive. Thirdly, the grounding conductor is connected to the ground bus bar in the load center. The ground bus bar is a dedicated terminal for connecting all grounding conductors in the electrical system. The connection to the ground bus bar must be secure and reliable. In addition to these steps, it is also important to ensure that the grounding system is properly maintained. This includes periodically inspecting the grounding connections for corrosion or damage and testing the grounding impedance to ensure that it is within acceptable limits. If any problems are found, they should be corrected immediately. When installing a grounding system, it is essential to follow all applicable codes and standards. The NEC provides detailed requirements for grounding and bonding electrical systems, and it is important to be familiar with these requirements. Additionally, local codes and regulations may also apply, so it is important to check with the local electrical inspector before starting any work. The size of the grounding conductor is determined by NEC Table 250.122 based on the size of the overcurrent protection device protecting the circuit. For example, if the circuit is protected by a 20 amp circuit breaker, the minimum size of the grounding conductor is 12 American wire gauge copper. If the circuit is protected by a 60 amp circuit breaker, the minimum size of the grounding conductor is 10 American wire gauge copper. The grounding conductor must be installed in a manner that protects it from physical damage. This can be accomplished by running the grounding conductor inside a conduit or by using a grounding conductor that is specifically designed for direct burial. The grounding conductor must be connected to the grounding electrode system. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or metal underground water pipes. The grounding electrodes must be installed in accordance with the NEC. The grounding electrode system must have a resistance to ground of 25 ohms or less. This can be verified by performing a ground resistance test. If the resistance to ground is greater than 25 ohms, additional grounding electrodes must be installed until the resistance to ground is reduced to 25 ohms or less. In addition to grounding the gutter, it is also important to bond the gutter to other metallic parts of the electrical system. This includes bonding the gutter to the metal conduit, metal enclosures, and metal equipment. Bonding ensures that all metallic parts of the electrical system are at the same electrical potential, reducing the risk of electrical shock. Bonding can be accomplished by using bonding jumpers. Bonding jumpers are short lengths of wire that are used to connect two or more metallic parts together. Bonding jumpers must be sized according to the NEC. Bonding jumpers must be installed in a manner that protects them from physical damage. Bonding jumpers must be connected to the metallic parts using approved connectors. In addition to the NEC, there are other standards that may apply to grounding and bonding electrical systems. These standards include the Institute of Electrical and Electronics Engineers, also known as IEE, Standard 142, which is the recommended practice for grounding of industrial and commercial power systems. This standard provides guidance on the design and installation of grounding systems for industrial and commercial facilities. It is important to consult with a qualified electrical engineer or electrician to ensure that the grounding system is properly designed and installed. A qualified electrical engineer or electrician will have the knowledge and experience necessary to design and install a grounding system that meets all applicable codes and standards. They can also perform ground resistance tests to verify that the grounding system is effective. Proper grounding and bonding are essential for electrical safety. By following the recommendations outlined in the NEC and other applicable standards, you can help to ensure that your electrical system is safe and reliable. Ignoring grounding and bonding requirements can lead to serious consequences, including electrical shock, equipment damage, and even death. Therefore, it is important to take grounding and bonding seriously and to ensure that your electrical system is properly grounded and bonded. The NEC, specifically Article 250, provides comprehensive guidelines for grounding and bonding electrical systems. It covers various aspects, including grounding electrode systems, equipment grounding conductors, bonding jumpers, and methods for grounding different types of equipment. One important aspect of grounding is the concept of a grounding electrode system. This system consists of one or more grounding electrodes that are used to connect the electrical system to the earth. Common types of grounding electrodes include ground rods, ground plates, and metal underground water pipes. The NEC specifies the requirements for the size, material, and installation of grounding electrodes. Another important aspect of grounding is the equipment grounding conductor. This conductor provides a low impedance path for fault currents to return to the source. The equipment grounding conductor is typically a copper wire or a metal conduit. The NEC specifies the requirements for the size and installation of equipment grounding conductors. Bonding jumpers are used to connect different metallic parts of the electrical system together. Bonding ensures that all metallic parts are at the same electrical potential, reducing the risk of electrical shock. The NEC specifies the requirements for the size and installation of bonding jumpers. When grounding and bonding electrical systems, it is important to use approved materials and equipment. Approved materials and equipment have been tested and certified by a recognized testing laboratory, such as Underwriters Laboratories, also known as UL. Using approved materials and equipment helps to ensure that the electrical system is safe and reliable. In addition to following the NEC, it is also important to follow any local codes and regulations that may apply. Local codes and regulations may have additional requirements for grounding and bonding electrical systems. It is important to check with the local electrical inspector before starting any work. Grounding and bonding are essential for electrical safety. By following the recommendations outlined in the NEC and other applicable standards, you can help to ensure that your electrical system is safe and reliable. Remember to consult with a qualified electrical engineer or electrician if you have any questions or concerns about grounding and bonding electrical systems. Their expertise can help you ensure that your electrical system is properly designed and installed, minimizing the risk of electrical hazards. Now, let's delve deeper into some specific considerations for grounding and bonding gutters. Gutters, as mentioned earlier, are exposed conductive surfaces that can become energized. Therefore, it is crucial to ensure that they are properly grounded and bonded to the electrical system. The NEC requires that metal gutters be bonded to the grounding system. This can be achieved by connecting a bonding jumper from the gutter to a nearby grounding electrode or to the equipment grounding conductor of a nearby circuit. The size of the bonding jumper should be determined based on the size of the circuit that is likely to energize the gutter. In some cases, it may be necessary to install a separate grounding electrode specifically for the gutter. This may be required if the gutter is located far away from any existing grounding electrode or if the soil conditions are not conducive to effective grounding. When installing a grounding electrode for a gutter, it is important to follow the requirements outlined in the NEC. The grounding electrode should be driven into the ground to a depth of at least 8 feet and should be located as close as possible to the gutter. The grounding electrode should be connected to the gutter using a bonding jumper. In addition to grounding the gutter, it is also important to bond the gutter to any other metal parts that are attached to it, such as downspouts and brackets. This can be achieved by connecting bonding jumpers between the gutter and these other metal parts. The bonding jumper should be sized according to the NEC. When working with gutters, it is important to be aware of the potential for corrosion. Gutters are often exposed to moisture and other environmental factors that can cause corrosion. Corrosion can weaken the grounding connections and reduce their effectiveness. Therefore, it is important to use corrosion-resistant materials and to protect the grounding connections from corrosion. One way to protect grounding connections from corrosion is to use a corrosion inhibitor. A corrosion inhibitor is a chemical compound that is applied to the grounding connections to prevent corrosion. Corrosion inhibitors are available in various forms, such as sprays, pastes, and tapes. Another way to protect grounding connections from corrosion is to use a protective coating. A protective coating is a layer of material that is applied to the grounding connections to protect them from corrosion. Protective coatings are available in various forms, such as paints, varnishes, and epoxies. In addition to using corrosion-resistant materials and protective coatings, it is also important to inspect the grounding connections regularly for signs of corrosion. If any corrosion is found, the grounding connections should be cleaned and repaired or replaced as necessary. Proper grounding and bonding of gutters is essential for electrical safety. By following the recommendations outlined in the NEC and other applicable standards, you can help to ensure that your electrical system is safe and reliable. Remember to consult with a qualified electrical engineer or electrician if you have any questions or concerns about grounding and bonding gutters. The NEC, in section 250.104, addresses the bonding of metal water piping and other metal piping systems. While it doesn't specifically mention gutters, the principle applies to any exposed metal that could become energized. The code mandates that these metal systems be bonded to the grounding electrode system to minimize the potential for voltage differences and electrical shock hazards. The bonding conductors should be sized according to Table 250.122, based on the rating of the overcurrent protective device for the circuit that could energize the metal system. It's crucial to use appropriate connectors and methods for bonding to ensure a reliable and low impedance connection. The connection should be accessible for inspection and maintenance. In addition to the general requirements for grounding and bonding, there are specific considerations for different types of electrical systems. For example, in a separately derived system such as a generator, the grounding electrode system must be connected to the generator frame and to the neutral conductor of the generator. This ensures that the generator is properly grounded and that fault currents can flow back to the generator. In a multi-building installation, each building must have its own grounding electrode system. The grounding electrode systems of the different buildings must be connected together using a bonding jumper. This ensures that all of the buildings are at the same electrical potential. When working with electrical systems, it is important to be aware of the potential for stray voltage. Stray voltage is a low-level voltage that can be present on metal surfaces, such as pipes, fences, and gutters. Stray voltage can be caused by a variety of factors, such as faulty wiring, improper grounding, and electromagnetic interference. Stray voltage can be a nuisance and can even pose a safety hazard. If you suspect that you have stray voltage on your property, you should contact a qualified electrician to investigate the problem. A qualified electrician can use specialized equipment to measure the voltage and to identify the source of the stray voltage. Once the source of the stray voltage has been identified, the electrician can take steps to eliminate the stray voltage. In some cases, it may be necessary to install a grounding electrode system to eliminate the stray voltage. Proper grounding and bonding are essential for electrical safety and for the reliable operation of electrical equipment. By following the recommendations outlined in the NEC and other applicable standards, you can help to ensure that your electrical system is safe and reliable. Always consult with a qualified electrical engineer or electrician if you have any questions or concerns about grounding and bonding electrical systems. Their expertise can help you ensure that your electrical system is properly designed and installed, minimizing the risk of electrical hazards. Another important aspect to consider is the type of environment where the electrical system is installed. For example, in a corrosive environment, such as near the ocean or in an industrial setting, it is crucial to use corrosion-resistant materials for all grounding and bonding connections. This includes using stainless steel or copper connectors and grounding electrodes. Additionally, it is important to protect the connections from moisture and other corrosive elements by using sealant or other protective coatings. In wet locations, such as outdoors or in damp basements, it is important to use weatherproof enclosures and fittings for all electrical connections. This will help to prevent water from entering the enclosures and causing corrosion or electrical shorts. It is also important to ensure that all grounding electrodes are located below the frost line to prevent them from being damaged by freezing and thawing. In areas with high lightning activity, it is important to install a lightning protection system. A lightning protection system consists of a network of grounding electrodes, conductors, and air terminals that are designed to protect buildings and equipment from lightning strikes. The lightning protection system should be installed in accordance with the requirements of the National Fire Protection Association, also known as NFPA Standard 780, which is the standard for the installation of lightning protection systems. When working with electrical systems, it is important to use proper lockout/tagout procedures. Lockout/tagout procedures are designed to prevent accidental energization of electrical equipment while it is being worked on. These procedures involve disconnecting the power to the equipment and placing a lock and tag on the disconnect switch to prevent it from being turned back on. Only authorized personnel should be allowed to perform lockout/tagout procedures. It is also important to use proper personal protective equipment, also known as PPE, when working with electrical systems. PPE includes items such as safety glasses, gloves, and insulated tools. PPE helps to protect workers from electrical shock and other hazards. Before starting any electrical work, it is important to inspect the work area for any potential hazards. This includes looking for exposed wires, damaged equipment, and wet conditions. If any hazards are found, they should be corrected before starting work. It is also important to be aware of the location of all underground utilities before digging. Contact the local utility companies to locate any underground utilities before digging. This will help to prevent damage to the utilities and potential injury to workers. Grounding and bonding are essential for electrical safety and for the reliable operation of electrical equipment. By following the recommendations outlined in the NEC and other applicable standards, you can help to ensure that your electrical system is safe and reliable. Always consult with a qualified electrical engineer or electrician if you have any questions or concerns about grounding and bonding electrical systems.